For the first time, the observatory discovered carbon dioxide in the atmosphere of an extrasolar planet, 700 light-years away from Earth. On the gas giant WASP 39b, it discovered gas. This finding sheds light on the composition of the planet. According to a research that was published in Nature, Webb might be able to detect and examine carbon dioxide in the thinner atmospheres of small rocky planets. Prior to discussing this amazing finding, let's go over some of the key characteristics of WASP 39b. Might this hold the secret to finding planets resembling Earth and provide an answer to the age-old query: are we really the only life on Earth? Hot gas giant WASP 39b has a diameter 1.3 times that of Jupiter and a mass 1/4 that of Jupiter. Its unusual puffiness is partially caused by its high temperature, which is approximately 1,600 degrees Fahrenheit, 900 degrees Celsius. The WASP team found Boca Prince, also known as WASP 39b, a hot Jupiter extrasolar planet, in February 2011. This atmosphere is dominated by water. The atmosphere of exoplanet WASP 39b included carbon dioxide for the first time. Located in Virgo, 700 light-years away from Earth, is WASP 39b. Unlike the cooler, denser gas giants in our solar system, WASP 39b revolves around its star at a relatively near distance, about 1.8 times that of the Sun and Mercury, making one orbit in just over 4 Earth days. 2 stars on this planet's transit periodically dimmed, leading to its discovery in 2011. Water vapor, sodium, and potassium have already been found in the planet's atmosphere by NASA's Hubble and Spitzer satellite observatories. NASA made available JWST spectroscopic data from WASP 39b. On the hitherto assumed to be arid planet WASP 39b, the observatory discovered water and hazy clouds. What's new is the confirmation of carbon dioxide's existence on this planet thanks to Webb's extraordinary infrared sensitivity. This discovery was made possible via starlight screening for exoplanets. With their telescopes, scientists sought to determine the composition of the planetary atmosphere. They looked at how different chemical wavelengths of starlight are filtered by the atmosphere. Researchers may be able to examine the planet's atmospheres by using transiting planets like WASP 39b, whose orbit we observe, rather than viewing them from above. A portion of the starlight is transmitted through the planet's atmosphere and partially blocked by the planet during transit, resulting in total darkness. Through the assessment of minuscule fluctuations in the luminosity of the light transmitted across various wavelengths owing to its expanded atmosphere and swift transit, gases absorbed various color combinations, enabling scientists to accurately determine the composition of an atmosphere. On WASP 39b, carbon dioxide detection and transmission spectroscopy performed superbly. On July 10th, the scientists used Webb's near-infrared spectrograph, NIR-SPEC, to observe WASP 39b. The exoplanet spectra, which range from 4.1 to 4.6 microns, provide the first conclusive proof of carbon dioxide in an atmosphere outside of our solar system. Planetary scientist and co-author Peter Gao of the Carnegie Institute for Science in Washington, D.C., says there's no room for doubt. It is an undeniable existence on WASP 39b. The discovery made by the new telescope on August 24, 2022, is its first comprehensive scientific finding. It also raises the possibility that Earth-like greenhouse gases exist on smaller, rocky worlds. One member of the JWST Transiting Exoplanet Community Early Release Science Team, who is an alumnus of Johns Hopkins University, expressed his fascination with the carbon dioxide feature's mass. He claimed that exoplanet science has made significant progress. This discovery pleases all scientists. An observatory has never previously witnessed such a radical shift. In the planetary transmission spectrum, which spans wavelengths from 3 to 5.5 microns, this results in a broad range of colors. This is crucial for figuring out how much carbon dioxide, water, and methane are present in different exoplanet forms. The initiative is being led by Natalie Batalha from the University of California, Santa Cruz. The discovery of a distinct carbon dioxide signal on WASP 39b, according to her, holds out hope for the discovery of atmospheres on planets with comparable terrestrial masses. Over time, the planet's origins can be revealed by comprehending its atmosphere. It's possible that asteroids increased atmospheric carbon dioxide and carbon on Earth. If lighter elements were destroyed by the star's radiation, the planet's atmosphere might contain more carbon dioxide. Mike Line of Arizona State University claims that carbon dioxide molecules are sensitive tracers that tell the story of the formation of a planet. We could determine the proportion of gaseous to solid materials that were used to form this gas giant planet. The JWST will measure many planets over the next 10 years, offering insights into solar system quirks and planet genesis. Even if a JWST-powered telescope is required to detect it, carbon dioxide might be present in atmospheres all over the cosmos. According to Batalha, carbon dioxide is a common element in all planets' atmospheres. In the future, astronomers hope to utilize the JWST to detect elements such as carbon dioxide in atmospheres, such as those formed by small rocky planets or structured stars like TRAPPIST-1. Some of those planets are interesting targets for the search for life because they are sufficiently remote from their star to support liquid water. According to Exeter University co-author David Singh, WASP-39b demonstrates that exoplanets can differ significantly in composition from those in our solar system. Diverse exoplanets could aid in our understanding of planet formation and evolution. The main source of the strongest spectral fingerprints is water. The amount of water surprised the researchers, who had expected to find some. With more water than our well-known ring companion, WASP-39b might have evolved in a different way. Water on this hot Saturn suggests that the planet evolved far from the star, following intense bombardment by ice particles. The evolutionary history of WASP-39b is intriguing as it traveled throughout its planetary system, potentially destroying planetary objects along the way. Hubble, Spitzer, and JWST observations have led to the discovery of WASP-39b, one of the most significant WASP discoveries. Its low surface gravity makes it an ideal candidate for atmospheric characterization as a bloated radius planet with a mass similar to that of Saturn. The sky is spectral and clear. Now, a group from Exeter University under the direction of Hannah Wakeford has combined the several datasets to provide the planet's most complete spectrum. The NIR-SPEC PRISM observation of WASP-39b is part of a wider research, since water vapor dominates the spectrum, but there are contributions from sodium and potassium lines as well as a high scattering slope near the blue end. 2 more planets are being observed by web-based planet study. The investigation, a component of the Web Data Science effort's early release, attempts to give exoplanet researchers access to web data as soon as possible. The objective, according to co-investigator Vivian Parmentier of Oxford University, is to swiftly examine early release science discoveries and provide open-source tools that the scientific community may utilize. This guarantees the finest possible research from the upcoming decades of observations and allows contributions from all across the world. Early research distribution is prioritized in NASA's open science policies in order to foster a transparent, inclusive, and cooperative scientific process. Webb can already see the atmospheres of far-off planets, and further discoveries are probably in store, according to Batalha. We are privileged to live in a time when the universe is being studied and the answer to one of the most important questions in life has been found. Are we alone in the universe? The solution may be revealed via the James Webb Telescope, for better or worse. Thanks to the capabilities of the James Webb Space Telescope, JWST, the discovery of carbon dioxide in the atmosphere of WASP-39b represents an important milestone in exoplanet study. This discovery is noteworthy. This discovery not only clarifies the planet's distinctive features, but also creates new avenues for investigating the atmospheres of smaller, rocky worlds that may resemble Earth. The makeup of WASP-39b's atmosphere sheds light on the planet's origin and history and shows that exoplanets can differ greatly from solar system planets in composition. With JWST playing a crucial role in solving the enigmas surrounding planetary formation and the hunt for habitable worlds, the detection of such atmospheric components raises the possibility that planets throughout the universe may still surprise us. One of the most important concerns facing humanity as we continue our cosmic exploration may be resolved with the aid of JWST data. Are we really alone in the universe? We appreciate you staying to the very end of the video. Remember to subscribe to our channel and leave a like on this video in order to ensure that you don't miss any upcoming James Webb Telescope updates. We also have another wild space tale prepared for you. Let us take you on another cosmic journey by clicking the video that appears on your screen. I'll see you over there.